In this tutorial, I want to introduce the POM. POM stands for Project Object Model and is at the heart of all Maven configuration. It's an XML representation of a Maven project held in a file named pom.xml. There should be a single POM file for each Maven project, and in the world of Maven, a project need not contain any code at all, merely a pom.xml. I want to talk a little bit about what the POM contains, because it contains up to 4 categories of configuration. First category is general project information. This includes things like the actual project name, a URL for the project, details of any sponsoring organisation, developers and contributors, along with any licensing information needed. The second category is build settings. In this section we can customise the default Maven build. We can change the location of source and test files. We can add new plugins. We can attach plugin goals to the lifecycle, which we'll be doing later on in the course. The third category is build environment. Build environment consists of profiles that can be activated for use in different environments. An example of this is during your development, you may want to deploy to a server, to a development server, whereas in production, you'll probably want to deploy to a production server. The build environment customizes the settings for specific environments, and the details for that are usually held in a custom settings.xml file, held in the .m2 folder, which we set up earlier. The last category is POM relationships. A project rarely sits alone or stands alone. It depends on other projects. Projects can inherit POM settings from parent projects. This is really the bare minimum configuration that's required in a POM XML. The outer tag or outer element is the project element. So that's obviously mandatory because everything else is contained within that. But also within there we have the namespace to the Maven 4 schema. Another element which is also mandatory, which is the model version, which is currently version 4. This is required in every Maven project and is currently the only supported POM version. Now the group of 3 elements here, the group ID, the artifact ID and the version, they're what is known as Maven coordinates. Group ID, this is an ID of a project's group. This is generally unique amongst an organisation and can be the organisation's domain name in reverse order. An example of that is, at the Den of Programming, I work on a number of projects which all belong to denofprogramming.com, so the reverse domain name of that is com.denofprogramming. The group ID is for all Den of Programming related projects. The artifact ID, this is an ID of the project. It's generally the name of the project. For example, min POM requirements is the name of this Maven project. Along with the group ID, the artifact ID defines the artifact's location within the Maven repository. The last coordinate is the version, which is an identifier used in the Maven repository to separate versions of the project. Just to demonstrate that this actually builds, I can select the project, right click, go to Run As, Build with the 3 dots, and type in clean, which will remove the old build from the target directory, and package, which tells Maven to run the package phase, which actually produce a new jar file. And run that. And that's one OK. What we can do is just click on the target, and then we have a new jar file. It's the min POM requirements project, 001 snapshot.jar. So that's created a jar file, but just to show the process that Maven goes through, we'll go through this in more detail later on, but just to give you some idea, it does a Maven clean, which deletes the target directory. Then it looks to see if there are any resources, or for example property files to be moved across. Then it calls the Maven compiler plugin, actually does the compiling of the source code if there was any, but as you see there's no sources to compile. Then Maven looks for the resources for the test, or any test resources, which there aren't any, so can't find any, it skips that. And then tries to compile any test code, and then finally run any tests. And at the end, the default is to build a jar file. What I'd like to explain here is we can override this, so we don't actually always have to produce a jar file. If we're doing a web application, we can tell Maven to produce a WAR file for us. I'll be showing that a little bit later on. So I just really wanted to show you that although we have bare minimum configuration in a POM file, we still have something that's really quite powerful. We can run a Maven build that will look for resource files, look for source files and compile them, look for test source files and compile them, and then even run tests. And really, we don't actually have anything in our POM file. All we have is these Maven coordinates that uniquely identify our project. That's pretty powerful. But how can Maven do all this? Where is it getting any configuration from? Well, the answer is the POM actually inherits from another POM provided by Maven. Now this has the name of Super POM. Despite its strange name, there is really quite an important concept behind the Super POM, because it allows the developer to minimize the amount of configuration in the pom.xml file. In our example, we only have 3 elements really that are the Maven coordinates, but at the same time we can still compile and build a complete Maven project. How's this possible? Well, basically our POM inherits from the Super POM, and combined they produce what is known as the effective POM. We can easily see that in Eclipse by just going over to this tab, Effective POM. What we see here is basically the combination or the result of combining the Super POM with our project's POM. Well, the result is we have a POM with a group ID, artifact ID and a version from our POM, along with everything else provided by the Super POM. Under repositories you can see the central repository, which is a URL, and this basically is the Maven central repository. This is where all the plugins get downloaded. Further down we see the configuration for the source directory and the test source directory and the output directory. All these things are using convention over configuration and are provided as a default. And that default is set up in the Super POM. A very, very powerful concept.